Chapter 2, Section 6 is all about theoretical and experimental probabilities. Only vocab words today, no examples. So probability is how likely something is to occur. And we have a symbol that we use for probability. It's just a capital P. And then we put parentheses around whatever the event is. So let's say you're spinning a spinner and you want to know the probability of it landing on a blue. You would write probability of blue inside of there. An outcome is the result of a single trial, so landing on blue would be an outcome. Sample space is all the possible outcomes. So if we have a spinner with like 1, 2, 3, 4, my sample space would be those options there. Those are the only options you can get. An event is any outcome or groups of outcomes. So probability of an event back here. The complement of an event is all the outcomes not in an event. So if I want the probability of spinning on a blue, the complement would be not getting a blue. The odds of something happening are the likelihood of an event comparing the favorable and unfavorable outcomes. And we'll talk more about how probability and odds are not the same thing. And then our two key words, experimental and theoretical probabilities. Experimental probability is the one we'll talk about last. That's the probability based on actual data collected during an experiment. Like if you actually flipped a coin 10 times and recorded the heads and tails and found the probability. Theoretical is the likelihood of something happening in theory. So theoretically, if you flip a coin 10 times, you should have a probability of landing on heads half the time and tails the other half. So by the end of this lesson, you should be able to find theoretical probabilities and find experimental probabilities. So theoretical probability. The probability of an event tells you how likely it is that something will occur. An outcome is the result of a single trial, and the sample space is all the possible outcomes. An event is any outcome or groups of outcomes. So here's an example. My event is rolling an even number on a number cube. This is just a die, or dice, we like to call them, like 1, 2, 3. So the event is rolling an even number. Your sample space, remember, is all your possible outcomes. So on a number cube, we have the numbers 1 through 6. The favorable outcomes, the ones that we want, are 2, 4, and 6. The possible outcomes for rolling a fair number cube are equally likely to occur. There's not one side that has like 2 2s on it. So when all possible outcomes are equally likely, you can find the theoretical probability by using this formula. The probability of an event happening is the number of favorable outcomes by whatever we want. So this is like the wanted outcomes, by the number of possible outcomes. So the probability of rolling an even number is 3 out of 6. There's 3 possibilities, so 2, 4, 6 of even numbers, and 6 total choices, 1, 2, 3, 4, 5, and 6. And then always reduce, so 1/2 is the probability. You can write the probability of an event as a fraction, decimal, or a percent. All are okay. The probability of an event ranges somewhere between 0 and 1. If something has a probability of 0, that means it's totally impossible. So an example would be like rolling a 7 on a number cube. There's only numbers 1 through 6. It is totally impossible to roll a 7. And then a probability of 1 means that it's absolutely certain. Like it has to happen. There's no other choices. So something like rolling a number less than 7 on a number cube, because your only options are 1 through 6. If you have a probability of 1/2, 0.5, or 50%, that means it's right in the middle. Everything's equally likely. Getting ahead when flipping a coin is just as likely as getting a tail. Both are a 50-50 chance. So, for an example, if a bowl contains 12 slips of paper, each with a different name of a month, so we have January, February, on and on, find the theoretical probability that a slip selected at random from a bowl has a name of a month that starts with the letter J. So remember, we're going to take the number of favorable outcomes and divide by the number of possible outcomes. So remember, we know the number of possible outcomes is 12. We have January, February, March, April, May, June, July, August, September, October, November, December. 12 possibilities. The number of favorable outcomes are just the ones we want. So in this case, the ones that start with J. We have January, June, and July. That's it. So there's only 3. Jan, June, July. So the probability that I select January, June, or July out is 3/12. And then we simplify this when we can, so 1 out of 4. So I have 1/4 of a chance, or 25% of the time when I draw, I will pick out a month that starts with J. The complement of an event consists of all the outcomes that are not in an event. So let's say we go back to our number cube. The possible outcomes are this 1 through 6. The outcomes ruling an even number are 2, 4, and 6. And the complement of ruling an even number are the ones that don't fit in. So we used up 2, we used up 4, we used up 6. So this right here is the complement. So this is not ruling an even. The sum of the probabilities of an event and its complement are 1. Remember complementary angles, they summed up to 90. This is kind of the same thing. A complement adds up to 1. So let's say that there is a 75% chance that it rains tomorrow. The probability of it not raining has to be the other 25%. There can't be like a 10% somewhere that would be something besides raining. It either rains or it doesn't, and these two added together equal 1 or 100%. So on a popular television game show, a contestant must choose one of 5 envelopes. One envelope contains the grand prize, a car. Find the probability of not choosing the car. So if we have the probability of choosing a car, out of our envelopes, only one of them, out of the 5, has the grand prize in it. So the probability of not choosing a car we know has to be 1 minus the probability of choosing a car, or 4/5. And I know for this one you can stop and just think about it. If only one envelope contains it, there's 4 that don't. So there's no car inside out of total envelopes. So I know in the real world we use odds and probability interchangeably, but in math class they are totally different. The odds describe the likelihood of an event by comparing favorable and unfavorable outcomes. So odds in favor of an event are the number of favorable outcomes to the number of unfavorable outcomes, and a lot of times we use colons. Odds against an event are the number of unfavorable outcomes to the number of favorable outcomes. So let's do a problem, and this will make a little more sense. Find the odds in favor of a spinner landing on a number greater than or equal to 6. So if we take a look at all of our numbers here, we have favorable outcomes and unfavorable outcomes. So which ones are favorable? Which ones are greater than or equal to 6? So we have 6, 7, and 8. So there's 3. And then unfavorable, 1, 2, 3, 4, 5. So there is a 3 to 5 odds of us picking a number greater than or equal to 6. Remember, this is different than probability, because if I asked you for the probability of picking a number greater than or equal to 6, you would say, well, there's 3 out of a total of 8 slices here. But the odds are 3 to 5. 3 in favor, 5 not in favor. So you can kind of see how this 3 is the numerator, but then you have to add the numerator or add the favorable and unfavorable outcomes, because this, remember, is your total. So odds don't deal with total, they just break up the possibilities into favorable outcomes and unfavorable outcomes. So experimental probability, this is the easiest part. Probability based on data collected from repeated trials is experimental probabilities. So you have to do an actual experiment, you have to collect some data, and then it basically is the same as theoretical probability. The number of times an event occurs, these are like our favorable outcomes, versus the number of times the experiment was done. So if I flipped a coin 10 times, it would be a trial of 10, and let's say I got heads 4 times. Favorable outcome would be 4 here. We know that that's not theoretical, it should be 5 out of 10, but life doesn't always end up like we want it to. So we can use that to solve these next two problems. The manufacturer inspects 2,500 skateboards. There are 2,450 skateboards with no defects. Find the probability that a skateboard selected at random has no defects. So the probability of no defects is the number of times we found no defects divided by the total number of skateboards that we have. And if we divide these, it's going to make sense to put this into a percent. We have 0.98, or 98% of the skateboards are not defective. There's 2% that if I randomly guess, I'm going to pick one that is defective. So manufacturer inspects 700 light bulbs. She finds the probability that a light bulb works is 99.6%, so most of the time. There are 35,400 light bulbs in the warehouse. Predict how many light bulbs are likely to work. So this, we're going to kind of use the probability backwards. She inspected only 700 and found that for the most part they work. Now we're going to extrapolate this and say that there's 35,400 light bulbs in the warehouse. So if we take this 34,500 and multiply it by our probability, we can figure out how many of them, on average, are defective. And if you multiply 34,500 times 0.996, we end up with 34,362. And remember, these are the ones that are likely to work. So for the most part, these light bulbs all work. There's only 638 that could be defective. And this is kind of using experimental probability with theoretical probability, because we're saying experimentally we got this percentage here. Now if we use that as a theory, we would only end up with about 600 defective light bulbs, which is pretty good. So, can you prove it? What's the probability that this spinner lands on a blue space? Your blue are your odd ones. So make sure you write that down. I know yours is not in color. And then what are the odds that the spinner lands on a blue space? So your two answers here should be different. And then experimental probabilities. Actually find a coin, toss it 10 times, record your results, and find your experimental probability. And we'll compare those tomorrow. Have a good night.